With this path, and I just open SSD and give it a name, simple beam. As it is, you will find this model of beam element, okay, but not using copy model. I want to develop a TD file for this. So for that, what I do is one more model, one more folder over here. Okay, so folder above, but now I'm just saying simple beam TD. What I further do is I click inside and I create a new TD file over here. TD files, you can simply copy and paste it over. Or what I do is I go to file and I say new file and save it in that folder. Okay, whenever ready. Wait, now a new TD file at this folder. Okay. So I want to now start from only material, right? I would want to define. I don't know how to define materials. So what I can do is I can straight away go to this SSD. Okay. And I see that a material has been modeled over here. Okay, thank you. Material has been modeled over here. Export this. Say that materials I would want to, get a text for that. Device tools. And I see that code is generated over here. And what I do is I go back to my TD file and simply say plus PROG AQUA, which is a module for definition of code, materials, and cross sections. So I am just giving it a heading that definition of materials and cross sections. So what I do is, as I remember, norm is a command to model the code, but I don't remember it at all. Then I can simply go over here and you see that here is something written as norm. Okay. So if I go to help, if I go to CADIM help, I see that norm stands for design code you can define and all. So what I do is to that model file, I simply copy this control C and write control V. So the code is copied from there to here. So this is how you only define now code, and it is IS IRC 112. I don't know what this COUN It says it is country code for boxed values within EN. I don't know what it is from here. And I give it a run and see whether this works. And it works. I go to report now and see what is generated in the backend. Then you see that in the report, it shows me that design code IRC 112 is generated. So you have successfully modeled a defined a code. And also I did not know what this information is, count, unit 5 and all. So I just deleted it and it worked well. Hence that what I wanted is there, right? Further, what I am required to do is I need to define material and it is concrete, let's say. So I copy this line or I simply start to write over here CONC and press F1 and I say NO is 1 and I say type is C, that is regular concrete, and FCN is and let me give it a run and it runs and I go back to report and I see that material number 1, that is M30 grade concrete as per IRC 112 is model. You see that is defined. Now what I do is I go at the top and as I'm not happy with the output in my report, what I further now do is I want bigger output. I want to know all information regarding this material. So I go back to the study and I say echo. Echo stands for extent of output. OPT, FULL, that is full, and val is EXTR is extent. I give this again a run. And if I now see in my report is now of 2 pages and giving me a lot of information about my material, right? So now here it tells me that Young's modulus is so and so, Poisson's ratio is so and so. All these things, although I have not modeled explicitly, it has taken the default values as per the FCN value, the class that I have mentioned as 30. Okay. So you don't need to give input for all these values yourself. Even if you define the class, that would take these numbers automatically. But it may happen that you're not happy with, let's say, E value, Young's modulus, 31,187. Then you need to go back to concrete, and there should be some EC over here. You see that EC is over here. So what you now do is simply say that hit 5,000. And I give it a run. In the report, and now EC value is 25,000. Return for NM square. Clear to everyone? Whatever you want to update, you need to give an input of it. But if you want to be with the default parameters, you can be there. So definition of concrete material is simply one simple line. Okay, report कहाँ से आ रहा है? ये बस स्टेडी है, इसमें कुछ वो ये नहीं. तो यहाँ पे ऊपर लिखा है report, go to home and go to report over here. If there is a new user, that user will not understand what you're exactly doing. Okay, so then in that case, what you do is in line number 6, you put a label over here, go to insert and put a label and say definition of code.
ये कंक्रीट नंबर 1 जो है ये आपने M30 डिफाइन करना है. दोबारा M30 30 0 तो उसको देने की
मैंने एक ही बार बोला M30.
नहीं, ये कंक्रीट नंबर 1 का मतलब क्या है? कंक्रीट नंबर 1
वो आईडी उसका 1 2
M30 का
आईडी 5 भी कर सकता हूँ.
दूसरा नहीं पड़ेगा
5 नंबर का मटेरियल material number 1, material number 2. Identification. I write it a table and I say that it is definition of materials. Okay. And over here, I say that it is N30 grade concrete. But if you go to a line and say, go to here, insert and click on this label, label will be added. As a result, it happens that there will be big or teddy file. So you can straight away jump to those places. It is like creating a new chapter to it. It will be better accessibility instead of scrolling too many lines to reach that place. So this exclamatory mark, this star, and again exclamation creates a label. Hash in between, it is a chapter. It is also for easier accessibility that I'm going to show you. What I do is I would want to go for definition of steel. Okay. I don't know what the syntax is, what the command starts with for steel. So I go again back and see that steel. Oh, here is steel in line number 16. And maybe I can straight away copy it from here, Control C, back and paste it over here. And it is material number 2 and it is type is steel. I don't know what this SIS is. Let me just go and check what SIS is. Better I go with things that I understand and I say type is reinforcing steel. And here in the manual, I see that B is for reinforcing steel. So the input is B. Then comes class is CLAS, that is 500. Tmax, let me see what Tmax is. Maximum plate thickness, but I'm going for now reinforcing steel. So this is not necessarily, given as an input. And this is the title, AP500, IRC 112. I remain with it. I could also add a title over here to this concrete material if you wanted any identification. So say TITL, and I could just say that it is N30 grade concrete. So this index, there will be type, there will be ID, there will be title for every material that you define. Type means in what action you want to put it, like that. Something that I understand, but I don't know what key value, what elastic modulus has been considered and all. That is a concern for me. So I go back to this aqua again and I execute the aqua and I go to home and now I go to reports and I straight away jump to material number 2 and I'm very happy to see that Young's modulus is 200 GPa over here, right? So I give smaller input, but I get, all data model over there in the backend. Take everyone. If you look at the output of my export file here, you see that concrete has been defined from line number 12 to line number 16. So this is the first line that you see is for concrete. At the same time, this SSLA is stress strain curve. This is also stress strain curve and this is also stress strain curve. And HMAT is material constant hydra. Hydra is for some other module required, some additional. I did not define that, but all the stress strain curves and all is there for me. So if you want to, it's just like giving an additional information by where we give E value. It's some additional, changed value of E. Similarly, it is this lines SSLA and HMAT is for that. Some additional information so that, from default, it is something else. Yeah. But you don't need to every time write that. So from the exported file, you could simply ignore the standard format, when it exports. That's why these lines are seen. Okay. But when that time you don't need to have it there in your database, in your in your TD file. Now, third task that Aqua can do is Aqua can define. So I need to just write a comment over here. I say that FE 500 reinforcing stick. Okay. So it is for the sake of identification, this commented comments that even if user sees this, he will understand, oh, this steel is defined over here, the material is defined, and so forth. Correct?
Why is it equal to in FE500 title?
Can you know that?
Text himself.
It's a text.
Add a finish in the text.
No, in text. Because it asks you, here it tells you what should be the kind of input. Here it tells you what should be kind of input. So material, okay, unit is no unit. Type should have a literal. Literal is this. Okay. So literal is this, literal. Okay. Then if you go to title, then it tells you here that it should be literal again 32 characters. So something here like. What you can do is you can create a new label, you can insert a new label, and you say that definition of sections. And I want to define a very simple cross section, a very, very simple cross section, a rectangular beam, rectangular cross section. But I don't know what the syntax is. So I can go back to my exported file and I don't see that I have not exported any cross sections. So I go to this SSD. I first create a cross section over here. Let's say new standard cross section rectangular beam. And this is the cross section. I keep it untouched and I simply say, okay, a new cross section is defined. I go back to my database tools and I export this again. And I say that, yes, I want to save. And I want to now export the cross section, this cross section, just to get that file. I just overwrite it, and here then I get section. You see that SREC is syntax for rectangle cross section. H is total height, 8 of rectangular cross section. SO is offset of reinforcement position, that is the cover in short. SU is top and the bottom reinforcement. SS is for the side reinforcement, 50 value. MNO is the material number that was used. So material number is 1. Reinforcement material number is 2. R type. What is R type? R type is reinforcement subtype. ASYM, asymmetrical. That means at top and bottom you can give different reinforcement values. So is basic reinforcement at top, that is negative. ASU at bottom. DA at the sides is the rebar dia, so on and so forth. So all that information I don't, apply my brain. I simply do Control C and I go back and just do Control V over here and also give it a rectangular cross section 400 by 800 mm, something like. And maybe I can delete a lot of items that I already have over here, but it is, no harm to me at the moment, so I keep it as it is. What I can further do is I see that this is such a long line and it is not accommodating in my screen. So it goes here and I have to scroll towards the right. So what I can do is I can go with double dollar, continue this line below. Ma'am?
Yes, section 3.
What will be your question?
First show content become
यहाँ पे
नीचे से।
ये यहाँ पे दूसरा जो टैब है वो है। हमने क्या ना उसको
एनफोर्समेंट वाले सब कुछ दे सकते हैं ना, मतलब जो है।
हाँ दिया ना सर यहाँ पे एनफोर्समेंट ये देखो ना मटेरियल नंबर MNO 1
अच्छा सपोज करिए मैं वैल्यू बोलता हूँ, अगर नीचे मान लीजिए कि 7 डायमीटर के 7 बार्स हैं,
हाँ
ऊपर जो है 25 डायमीटर के 4 बार्स हैं, साइड में 16 डायमीटर के मेरे 3 बार्स हैं, तो वो बता सकते हैं।
yes,
मतलब जो है कि कहीं और
yes, you can get
लिख दे सकते हैं कि क्या नंबर दे सकते हैं।
स्टीरअप दे सकते हैं नंबर ऑफ लेग्स दे सकते हैं आप और उसका एरिया दे
एग्जैक्ट सारा कुछ कर सकते हैं के साथ में।
मतलब एक है 2-3 लाइन्स होती है उसके नीचे जैसा मटेरियल के नीचे आपने कैसा SSLA देखा वो एडिशनल लाइन था तो एक मेन मटेरियल का लाइन है उसको नीचे वाले जो लाइन से वो कनेक्टेड थे आई शो यू दैट so this was a way but I would want to go for a box girded cross section okay and what I do is now is I go to cross sections so I go to basically Sophie Plus wherein I can model the box girded cross section do you have any cross section box girded cross section drawing should I use my own files
कौन भी कर सकते
Hmm. Okay, let's define yesterday's cross sections. Okay. So, so if I want to show you the input of how it can be done, let's say that there is uh, so this is a section 1. Okay, the input looks like this. Section 1, and it says that freely defined cross section and material number used is 1. Reinforcement number, material ID for reinforcement is 2. MRF is for reinforcement. MNO is for cross material number of for the cross section, material number for of the reinforcement. Title is mid section. Okay. POLI stands for polygonal cross section element. So we modeled yesterday, using those polygon. We did point in area, but that was a polygon, right? So the material for that polygon, the outer boundary was 1. That is concrete. That's why you need to define that material again. So this is a subheading of section. Okay. So then you define vertex, the polygon vertices in absolute coordinates. So what you started to do is in that Sophie Plus, find points like that. Okay. But here you will have to define y and z coordinates with respect to your origin, which was there at the top. Okay. That you can generate a cross section, but you don't need to really be worried about, there is way to do that just by exporting. So what I now do is, so here is from here to here are the vertices for the external boundary. And since it is box section, this is for internal boundary. Here you see that material number is 0. That means the internal boundary, the opening don't need any material and vertices are from here to here. SPT, geometry and stress points. Stress points we defined, right? So that stress point is over here and I'm giving it a name bottom. So stress point is top right, stress point is top left, and I'm giving them the coordinates for that. Okay, this is how you define the cross section. There is something called cut. So if you want to define shear reinforcement and go for shear design, then you need to create shear cut from where cross section is being cut for shear. Basically, that stands for that. What I do is now you see that such a big text, but how it can be simplified. I will show you that over here. I go to this place and I say cross sections, new solid section, reinforced concrete. I give it a name mid section. So we'll create only one cross section. I go to stages. I create a new stage. I say it is section. Here 100, that is flange activation. So export yesterday's cross section directly. I'll do that. That is a better way. Why it takes so much of effort? So I go to this SL, I open yesterday's model file, R2 yesterday's model file, and I simply go here to database tools and I say export to DAT. I go to cross sections and I want to export this mid section, right? And I simply say okay. A table file opens here in the third tab or fourth tab, and the cross section is now exported. Now what I do is I simply straight away go here to section 3, line number 17. Okay. Copy this data from here to here. All vertices, Control C. I go back over here and I model, I paste it over here. And yeah, it was supposed to be my cross section number 2 in this case, right? Section number 2, ID is 2, right? So I say it is ID 2 and the material. Basically, let me understand what it is. Additional cross section properties and IT, as sir was saying yesterday, torsion, it is 100% considered over here. So you could give 0.9, 0.7 or 0 or 0.1 or whatever you like. CS is construction stage number 10 for girder activation. If you remember, we had given girder be activated in stage 10. And in that stage 10, this polygon with these vertices will be activated. This is the idea, right? And the definition further is in stage number 100, flange activation, that rectangle is now here. So what care you need to take is 200, 201, 2 and 203 should go and end at 200 only. So it should be a closed polygon. Similarly, starts from 100, goes to 111 and gets back to 100. So it closes itself. Then only it becomes a closed polygon. Now what I do is I just give this a run. Before that, I give it a comment over here. I say here it is mid-section definition. Okay. And now I give it a run and see in my report what is getting generated. Why is it taking so much time? So it says definition of core materials in cross section. So what it says is 200. Let me go to report, go to input data over here and see. So material number 4 is not there. That's correct. Line 38 is a problem. So 38 is a problem that material number 4 is not there. How to debug it? So here it says that material number 4 is there in the section and it is, the problem is in line number 38. So I go back here to line number 38 and yeah, definitely there is no material number 4. So it's a problem. So it says that polygonal opening first vertex is not within the section. Okay. I don't know what it is. Maybe it's problem with my unit and maybe it's not taking up in millimeters. Let's see. So it also says that cross section number 1 has been defined already. Okay. So H is not positive. Okay. Let's see. Let's debug. So cross section number 1, number 4, and I'll have to create another material or just for this, sake of demonstration, I'll do Control C. Okay. Now just give it a run. Problem. I go back.
So that's how.
Okay. That's fine. So line number 17, it says 17. But I'm defining over here section 2, right? I just taken this down. Let me just see whether the problem is with this. Problem is with this 17 and not my new cross section basically. It went through. Let me see. This cross section is generated, right? So I have just commented out that polygon that is above, just because I had to create. You get that even if it is a complex cross section with such kind of vertices and all, you don't need to yourself go and type in those vertices. You can export these cross already modeled using Sophie Plus. So this is how you balance. So whatever is easier in Sophie Plus, you use Sophie Plus for that. Whatever is easy in Teddy, you. Okay. Now let's proceed. So we need to now model a beam element, right? In this. So what we now do is I create a new chapter or I create a new and name of the module is plus frog Sophie MSS defines your geometry. As I had said that any finite element program that needs definition of materials, definition of cross sections, so that we are done with. It also further needs definition of nodes and definition of elements. So we need nodes over here. Okay, we need to define nodes over here.
पहले नॉर्मली नोट्स आता फिर क्रॉस सेक्शन डिफाइन करते हैं तो यहाँ पर पहले क्रॉस सेक्शन
ये सेम है ना, जैसे हम स्टैट में वो हमें प्रॉपर्टीज पता नहीं है और हम खुद ही सेक्शन ड्रॉ कर रहे हैं.
वही
ओके.
सर आप एक्सचेंज कर सकते हो. In Sophie MSHC, now generate nodes, right? Only two nodes, node number one and node number two, nothing else. So that what we need to specify is what kind of system it is. That is three-dimensional, two-dimensional, what kind of environment it is going to be. For that, I have a command called that is definition, and we define same system always. That is global system definition. SPAC stands for three-dimensional system. So here it says literal in combination with GDIR defines the orientation. Formal literals SPAC extracted are still valid when in the remarks. Okay. SPAC spatial system basically. Right here 3D as well, no problem. There is 10,000 and GDIR is direction of gravity and that is negative Z is over here. Unit 5 I have added over here. Unit 5 stands for structural engineering sections in millimeter and system in meters. So that thing was there in, we used to do right in Sophie Plus or SSD. 5, then you define sections automatically that will be taken as these are now in millimeters.
इसलिए अपने 1000 से मल्टीप्लाई करके वहां जाएगा इसी आप डायमेंशन कहते तो 1000 से मल्टीप्लाई इसीलिए आपने जैसे
Now what I further do is this is after this what I need to do is I need to define a node. Okay, so I don't know how node is defined. Okay, so I go back to my Sophie Plus, create one line element. I know here I give it a cross section and I go back over here and maybe give it to group number 10 so that or 5 I can identify later. And I go back over and draw 10 meters line like this with a cross section. I go back to 2D wire now and create support condition for that. See what syntax I get, and I just copy that syntax to my this. Now I go to database tools, export to DAT, message A and C. Okay, so give me some time. I'll do structural elements, and I now see that it is Sophia message C. Unit is 5. This is this what we defined, and we also now want to model SPT. SPT is our point. So maybe I can straight away copy this entire thing. For code, SPT is 1. So basically I just go back and see the information that the SPT is structural point, and it is modeled at X coordinate is 0, Y is also 0, and Z is also 0 for that. It further has got fixed property support condition, basically saying that PPMX. PP stands for PPMX. Okay, so I'll just keep it here PPMX. That means I'm restricting. PP means PZ restraint. You can give it a shortcut PP. Personal restraint as well.
Let's say we're done.
So what I'll do is I'll only this and give it a run. Okay. So what I have is only SPT number and its coordinates, and I am not giving it any cross section and anything yet. Okay.
चलो मान लीजिए कि पूरे करना है एक डायरेक्शन मूव करना है पीपी की जगह आएगा जैसे हमें सब में टॉर्सन रिस्ट्रिक्ट
रेक्टेंगल सी वाला कॉपी
अलग करना पड़ेगा एक साथ कंटिन्यू कंटिन्यू करनी
सेट करता हूँ दूसरे साइड
Section का
देख देना.
PTR
So I give it a run and see
ये तो चाहिए
what is generated. So I go back to my report and see that nothing is generated. So I need to add this EXTR, and maybe then I can see what is generated in my report then. Now here I can now see that it's a weird information yet. Maybe I can add a node more and it may show me up over here. What I do is when it comes to support condition, instead of writing PP, I write PZ.
नेक्स्ट
NX is Z axis of local coordinate system. Concurrently. So one stands for उसका local Z जो है is in
एक्स वाई मैच कर रहा है जेड की डायरेक्शन जो है कि अपोजिट है उसकी जो है जो एक्स वाई मैच कर रहा है
XY match.
एक्स वाई मैच कर रहा है जेड जो है मेरा जो है
Opposite.
माइनस में
Volume बाहर आने वाला output है.
और एसएक्स का एसएक्स
x axis of local coordinate system. ये हम z axis का orientation दे रहे थे, ये हम x axis का दे रहे हैं, क्योंकि it is with your आपने तो फिर भी चलेगा. Let me just structural point number 2. So I copy the same line from top by simply doing Control D. So I line and I D. The line which is there at the top gets copied below. And now I say that it is going to be my structural point number 1 and x value is going to be 10. Y is 0, Z is 0 and rest is all same, but I want to release Px. I also restrain Pz and I don't think that I need to extend Mx as well over here. On one side Mx restraint, that should be sufficient. This input Mx, that may not, let's see. I'll delete it after some time. So calling it a point, okay, I'll call it a point and I say that it's point 1 and below is point number 2. And now I give it a run, or what I do is I add structural line which is SLN. The command is SLN structural line and I say NO is 1, line number is 1. NPA stands for point at start of the line and that is my point number 1, structural point number 1. Then I write NPE. You see that NPE over there, point at end of the line, that is number 2. And what are the information, additional information you need to give is for a section, right? So let me look out for cross section. Where is it? So SNO says that it is a cross section and I give it cross section number 2. What else we need? We need to put it inside a group, right? Then I say that group number GRP. I'll give it group number 5. What else you need to give? Right now, let's see. SDIV you can do.
The 5 नोट डिफाइन करने को भी कर सकते हैं.
हाँ, ये जो है SDIV, number of elements to. अगर आप ये डालते हैं S डालते हैं तो आपके 5 एलिमेंट जनरेट होते हैं.
मान लीजिए 2 नोट डाले हैं मुझे 1 मीटर पर और बाकी 30 पे 3 मीटर करनी है.
अच्छा,
वो वेरिएशन कर ही सकते हैं. वो कैसे करेंगे
वो आपको फिर अलग के लिए एक तरीका मैं आपको दिखा दूं. This is SOPI MSH C. In SOPI MSH A we are going to do that. Let me give it a run and see what is getting generated. Okay. I see that nothing is generated. Making mistake somewhere, which I don't know. I'll just go and debug. That nodes, it should give me node number, it should give me X, Y, and Z polynomial. There's something, messy. I don't know what it is. Let me try to debug. So this looks good. I don't see any problem with this. Problem with this. This is also fine. Then what I'll do is I'll just see. Maybe I'm missing out on some control option. That is control mesh. I say CTRL MESH and I say start mesh generation. Yeah, that was the thing. So I was just giving control mesh 0 as an input, which means that won't be creating any nodes in between. That's what that. Left hand side, there is a pin with you see at the top, that is torsional restraint. So, and here is there in the X direction. If I just change it, let's say, if I just change it, let's say that I remove this MX from here, okay? The torsional here, and there is no here, then there will be rails added. Rails added means it is now a roller in that direction. Or let me do it to remove PY. So I go here and I remove this PY from here and Y is added in the rails are added in the Y direction. So on and so forth. So there is a lot of info here.
ये अच्छा है कि ये क्लियर बता रहा है, बाकी मुझे दिखता नहीं है इसमें रोलर है।
ये जो रिपोर्ट है इसमें भी ये सारी चीजें दिखनी चाहिए. So I go to summary of beams. Yeah, you see, look at these nodes. Nodes. You see that node 1 and 2 at X is 0 and X is 10. Support condition is here, PX, PZ, whatever you write. Very clearly it shows. And these nodes 1003 are generated as a result of my meshing at X 2, 4, 6, and 8. Like that it works. So what I want to tell you is that eyes are never closed. You know what is going on inside. You are butterfly, or you look at it in the wind graph. So all these different post windows will help you get confirmation again and again about your model files, right? Even if you are modeling a load and you want to confirm that, yeah, really the load has been modeled or not. Suppose you have modeled a load in Sofistik Plus. कि नहीं समझ में नहीं आ रहा है, लग रहा है या नहीं, लगा तो रहा हो लेकिन लग रहा है या नहीं है. So then you can simply go to that this has been applied on so many things. Step you can take is you can go to Windsurf and see visually how it has been modeled. You don't need to go back to the same place where you are really doubtful about, and that was Sofistik Plus. Clear to everyone? Let's now just proceed. I go back and this subdivision was here -5 I entered. Okay. And if you read this, if a number less than 0, then number of elements to be generated. That's the reason here it has generated 5 elements. So 1, 2, 3, 4, 5. If I put 5, okay, or positive 5, then let me see how the mesh is generated. It is at every 0.5 meters. So again, that's a control with you. I go back. I've modeled nice P, which is stable system. Let me make it stable. It is unstable at the moment. So what I could do is I could write I and PZ. If I show you, okay, it's a pin, but a shortcut to this P, then also it is PX, PY, PZ. And there is nice explanation for all these things here inside this, very detailed. And what I do is here is no PX, okay, MX. So it doesn't protect. And I give it a run and I just proceed. Nice comments to this, and I say that insert here, and I testing generation. I say here that structural point definition. Okay. I want to perform analysis on this, but before performing any analysis, I need to define loads, right? So definition of loads, you need to define those loads. I would want to perform my combinations as per Indian standard. I have provided you with a reference file for the actions. You do it in those define action in these actions. Okay, from this action map, all these actions over here. Basically, and this is as good as writing that action manager in the tabular format that we were seeing. So action and type is G underscore one, GA part and superposition type. Okay. And you give it a title. So you don't have to do anything, just give it a run, see that whether it works. And I see that model over here in a tabular format, and that works well for me, and that is fine. Further, now what I need to do is I need to model my load cases inside these actions, and I don't know how to do it. Okay. So I go back to my Sophie Plus and I go to load. And factor of derivative is 1, and I call it an external load EL, and maybe not assign any action. Let the action be Q. It is just for my reference. And I say simply okay, or I'll add one more. I'll give this EL1. EL is the external load, okay? So I give it like that. 2, 3. What I can do is I can define a point load, okay, as a free point load, as an element point load, okay. So I need a point here, then I need to define a point load. I go to line load, so since it is a line, element line load, I say enter, and I keep it in EL1, okay, and I say simply okay, a line load is modeled. I go to now free line load over here, not element line load. I go to free line load, and I give it this location to this location, same the entire line, okay, and its intensity is also 10. Overlap on top of this. I create a point load, free point load, and I put it, I apply it at somewhere here at the mid, and I give it an export now. So I want to generate the syntax for this, how to model this. This is the idea.
समझ रहा हूँ कि अगर मेंबर का साइज कम ज्यादा होगा फ्री लाइन लोड से वो एडजस्ट हो जाएगा और अगर मान लीजिए प्योर लाइन लोड दिया तो अगर वो जो है मेंबर का साइज चेंज होता है तो उतना ही रहेगा लेंथ उतनी रहेगी लाइन लोड
एग्जैक्टली अपोजिट
उल्टा
एलिमेंट लाइन लोड है, एलिमेंट से जुड़ा है. अगर एलिमेंट आप उसको छोटा बड़ा करते तो एलिमेंट इट विल
फ्री लाइन लोड में फिक्स रहेगा
फ्री इज फ्री
मतलब वही लग रहा है आप एलिमेंट भी किस
एलिमेंट मूव कर सकते हैं
फोर्स में रहेगा
देखो. And I go back to my SSD, and now I go to database tools, export to SSD as well, right? So I go to loads, and I would want to now export these 3 load cases, and I say okay. It says that this export file already exists, and do you want to really overwrite it? I say I want to overwrite it. Now I see that in this Sophie load, here is my load file. So how it is modeled, let's see. So it is simply LC1 G underscore 1. It is very easy, I see. So I straight away go back to this and I say plus PROG, so we load, give it some heading, load efficiency is small case, big case is not a problem for this, okay? Uppercase, lower case is not a problem. And if you're writing any heading and all, even if you're making spelling mistakes, that is also not a problem. So I write LC and I open straight away help. And I say that it is definition of load case and I said LC number is 1, PYPE type is, let's say that it is G underscore, or I say none for now, none, because I'm going, or let's see, let's give it G underscore. I already defined that action, no? Above. Let's use it. FACT, I don't need to give any factor, but I do FACD, that is self-weight factor, okay, 1, and FACT as well, okay, let's do 1. And I just give this a run. So this is definition of your self-weight case. And what I'll ensure is I'll also add over here as unit 5 so that you know my unit 5, you know what it is. As a result, you see that load case 1 is generated and it says that factor for dead weight is -1 and rest all those factors, whatever it is. So what I do is I have modeled now one load case, and what I now do is I go to analyze my system. So I want to verify whether it has been already modeled or not. That can be done through WinGraph as well. But before advanced solution engine, and I write LC1 and I give this it is over there and I can see that it is right.
Assigning the certificate.
So
The pattern name, that is for assigning.
अगर आप इधर FACD अगर 10 करोगे तो 10 times हो जाएगा, 10 times हो जाएगा.
It is for that load.
Factor for
STS you find it.
it's you assign a factor for dead load. You assign factor for dead load. You are assigning factor 1 for dead load. You can assign factor 5 for dead load. So it's not 0, 1. 0 means no, not assigned. 1 is assigned. It's not that. It's you assign a factor.
Could be any number. But also
Graph, I say all loads, and then over here, when my factor is 1, it self-weight, the load. And make this factor, let's say 2. Yeah, opposite जाएगा.
Opposite.
Yes, yes. You see that it is factor 2 now. 18 का twice over it. What you can do is, if there are such kind of queries, you can, quickly model and just check 1 क्या तो क्या होगा, 2 क्या तो क्या होगा. So that is how you really work. Because on a big system, you should not work. Finite element, it's always, model a small beam, understand what, the is doing at the back end. Okay, doing this is this. Okay, then you a step ahead. Always a very, very small beam. Yeah. Now you see what I do, ma'am, is here FACD is 2. 1. If I do FACD 2, then again a factor to it. Like that it works. Okay, clear? Now I'm interested in modeling load case number 2, LC, NO is type is, what type should I give? G underscore 2, you mean to say? Okay. very important for further automatic, those combination rules are there for that type of, right? You need FACT if at all you are going to use. Yeah, this is fine. You can give it also a title. I give it a title. And line, but under this there should be subheadings which should say that it is a point load, element load, free line load, or so on and so forth. I don't know the syntax for that. So I go back to this and look out for syntax. Where was that? Yeah, here it is. So if I go for line, line, then it is possible. But I go over here and line. Okay. I write say this free line loading. Okay. But instead of for a free line loading, if I give a reference, say that reference is my structural line, SLN, okay, and number of the reference group, what I gave, right? I can see group number was 5. That line on which I will want to model my line load. And further, it asks you what kind of intensity or something, P1 value or something it would ask me. And I simply write over here, type is PYP is type and direction. I give it PG, that is gravity direction. And I give P1, that is the load value at the first, and I give 10. If I want to give my units, I can specify units over here as well. And then nothing else. It should take value from P1. This is what my line of thought is, and I just give it a run. Yeah, it worked. I go back, we'll see, and that nothing more than that. Huh?
P1 के define किया P1
Again, what I'm really missing out on is title is back, and I just see what they have done. So SLN is 1, this is type is 1, P1 and P2. Okay. P2 is mandatory. Assumption that P2 is not mandatory is wrong then. So let me write P2. All we have defined, right? Type is there, SLN is there, and all is there. 2, similar by 10. And let me just verify whether I have right. Oh, no, the thing was that SLN to SLN, it should be 1. Structural line is 1. I could select a group from here, BGRP. My input was BGRP, then it was that was a mistake that I was doing, and let's see whether it works. It's there, right? So this is how you proceed step by step. Very slow. You don't know how to model point load. Now we already have syntax for point load. You can simply copy that entire thing, paste it over here, and just make some changes, at least the load intensities and all, and you will be through. Yes. Good. So for that, what you need to do is model an axis. Huh? And that is your choice. आप बिना compare करके भी कर सकते हो आप. but I'll show you how to model an axis. So what you can do is, okay, now since ma'am is asking मेरे को axis बनाना है, तो मैं यहाँ पे जाके axis बनाऊंगा, उसको export करूँ. I'll show you the syntax for axis. You see this GAX is geometric curve or an axis. You see this type C is axis. Then this is an axis horizontal plane में उसका कौन सा डायरेक्शन क्या वेक्टर में जा रहा है. लेंथ में दे रहा हूँ उसका रेडियस ऑफ कर्वेचर दे रहा हूँ. R stands for radius. If you give some value 250 meters, then it will take that arc shape. Then further you can define the axis. You saw in the workshop, right? You can define placements on the axis. Then you can start to define structural lines between those placements on those axes. So everything on axis based modeling in that workshop that could be done using TEDS, or you can do it that way, export it into TED and keep doing like that.
Just out of the context, can we offset the axis also with that particular?
Yeah, for secondary axis, and you can offset it. And we did that offset rate. We did the secondary axis.
Where the transitions were coming from.
But you plus no everything over that. If export that and check.
Are we did to take the transition?
So sir is asking whether the inner range and this video on that, right? I'll
Wait for
that over here. So I'll be rotating that. See, what has been done is there are two axes now modeled in the same place. One is for this is three span continuous PSC composite. So in that case, X slab is going to remain in curvature, but my girders are going to remain straight. So for girders, modeling three axes, one here, second here, and the third in the third span. Now you see how I change my placements to be able to, sir asked. I took an angle, इतने angle से उसको tilt करना है, and I gave that angle over. Yeah, this is manual ना. मैंने manually बस angle डालूंगा तो ये पूरा ये देखो ना, पूरा उसको कितना एंगल से जाना है 4.43 exactly. I need to really measure it. AutoCAD में it comes like precision बढ़ा दो काफी अच्छे से precise किया जाता है. Now the problem over here was, okay, that you see over here is placement, okay. It is not parallel to this deck. That's the problem now. ये तो हो गया कि अंदर का ही जो लाइन है ये this is this that is so that's fine. Okay, now the problem with is that this diagram should be parallel to this deck, and I'll just rotate my placements now to make it parallel to the table. On to like this is also a way of automation that you have such spans, then you change length of the axis and automatically your span lengths keep changing. And let's see finally how the model looks like. Diameter shown. It was straight and I made it curved. So now it is curved already, I can make it straight. I can also change its length. I can change its, you know,
Then once you change it to the straight once again, you define the geometry back to the straight one. We have given it the diagram is simply there. You have to bring it to zero.
yeah, so what you will have to update parameters is that you will have to remove all rotation for diagrams. Placements basically. मतलब यहाँ पे एक्सेस का जो डेफिनेशन है इसमें आपको हॉरिजॉन्टल पड़ेगा वर्टिकल अलाइनमेंट तो कुछ डालना है प्लेसमेंट्स का जो later stage, but automatically your lines, structural, everything will start to adjust now. Your radius. And it is recorded. You can simply look at it and start developing model files. If you develop such kind of a one-time job only, then you'll have to only keep.
ये एक्सेस पे कुछ मॉडलिंग के लिए किसी और मॉडलिंग
Modeling
तो पार्ट तो कल हमने दिखाया था ना तो लाइन को
इसको भी यूज कर सकते हैं ये भी एक्सिस को यूज कर सकते हैं
अच्छा जैसे कर्वेचर में देना है तो कर्व लाइन ऑटोकैड में डाल करके उसको सिलेक्ट करके लेन पाथ तो वहां से भी दिखाया जाता है
वहां से भी दिखा सकते हैं ऑटोकैड से भी दिखा सकते हैं हम ऐसा डाल भी I wanted to further discuss. So you can define access, okay? And while an access export it and you will get. So I have done this. So I showed it that day, right? So I don't remember. I did not show you this file.
दिखाया था
यही दिखाया था. Same. When?
First,
फर्स्ट
So I don't need to. Okay, I'll show it to sir. Wait. Sir was not there. So in this, what I've done is, so I've got these 5 buttons here at the top, and as soon as I say run calculation, takes these input parameters. It is as good as the template we used to define. Okay, span length, axis at start, and alignment radius, width, and all definition of the load intensities. Further, these are station points for your cable profiles. So 0, 0.2 L, 0.5 L, 0.8 L, and N. Here you input your Q value, the local coordinate in the horizontal plane. So this will be automatically taken. Currently it is made like that. I input here V and VO here. So this is from the bottom. This is from the socket. Not yesterday we were seen from the top. 3.5 meters here and now it goes down to 0.2 meters. So there are 6 cables over here in my model. So here is the value. So 1.89 was the V value, and here as you go ahead, it becomes 0.715. You can input number of strands over here, okay? And further, what you need to do is you need to simply give it a run function. Button, Sofistik opens in the backend. The TD file basically gets updated as per your input. and it generates that. Now what I do is I want to see my TD file. So I just open that button and TD is open here. Okay. Now what I do is it does, it takes data from there. It has got module aqua. I'm defining knob, that is the design code. I'm defining the concrete, I'm defining steel, I'm defining this, that, same cross section that, the way we defined it is same definition. I'm further going ahead, something template wherein I'm bringing in the data from that Excel sheet to this place. I go on to define an axis here, okay, that I showed you right now. And then I define my geometry, box girder is one single line. And also I define my support. So these are my supports, okay. So, okay, I'm doing that. Then I go to Sofistik load, same loads that action manager that I showed you is over here. Then I define only 2, 3 load cases, load case 2, 3, 4. You saw it, I did it using SLN here, I'm doing it using beam, and I'm using from group number. The different way of modeling the same thing. Sofistik can do one thing in 10, 15 different ways. You can use then you can use group number, you can use actual cost. Yesterday, okay, 301, 302. I'm placing that in that, lanes which are now defined, okay, and I'm running an ASC to execute those. And here is maxima for, getting an envelope for those things. And here I'm modeling tendons, okay. Once I model tendons, I go to CSM, that is I do construction stage manager definition. These are all my pre-stretching, cable stretching stages. And further, after that, I'm going for different superpositions for my ULS, live load leading, thermal leading, this and that as per that table of IRC 6. Further, I go to AQB, check, basically the flexural check, and here I go with the SLS check. Now, what I do is, just for the presentation, what I do is I switch off all loads, okay, not the loads, let me generate, switch off something below this, how it is working, okay. So it only now generates my model, and I just close it down over here. And now I say that my alignment radius is 0 meters, and I give it a run. Stick opens in the backend, starts to regenerate the geometry. Okay. I could remove that circuit load as well. Okay. Release. Oh, माइनस किया मतलब वो निकल जाते हैं ended definition. Yeah. So it is done. Yeah. Now I want to see my butterfly. What has been modeled? The visualization. And see that it's a straight box girder. And I see that here all my load cases and everything is there. Now what I do is I go back here and I change my alignment from 0. Also I change my span length, maybe 42, 45, brand, any value. Okay. And I say run calculations. And now this is the updated geometry. Now it takes the updated data.
price price
Because
सेक्शन दूसरा और दूसरा
I did not save the file. I removed it from there, but I did not save the file. Maybe I can just say stop. ऐसा हो जाएगा, ऐसा finish. Like that, because the database gets corrupted because then it is and then. So I open visualization and I see that it is curved one. My span length is also changed. Also, what you can see is I did not run tendons. Okay. So let me just go back. I have removed this. I want to show you the cable profiles getting updated basically.
हेलो रिटेस एक बात में दे रहे हैं ट्रांजिशन में से देखो
That's are also getting adjusted. I already specified those station points, right? Point to L, B cell. I can keep changing it the way I want. For example, they suppose you have got a metro rail, we just got like 70 such spans. Then this is the module 5 meter span length. This is the radius. This is that. Load is this. Give it a run. What it does is finally it generates a report. It does construction stages, updates the loads, does everything, and finally tells you the last page is SLS stress at girder bottom. That is what I'm interested in. And also it tells that in each of the pre-stressing stages, what is the stress at girder top, basically. How होगा ना वो time पे. तो वो requirements. It should be in compression, should not be in tension or one in tension at girder bottom. What I'll do is I'll go back over here. Okay. I'll go down, increase my number of strands. Okay. I know the profile. I know which strands to be increased. Like open the report from here. Just check, go to the last page, just check. It is just 60 pages report every time getting generated with all relevant information. Sequential. See, oh, now it was 4 MPa tension. Now it is reduced to 2 MPa. Further, I need to increase 2 more strands. I do that and I reduce my take compression 1. At least your design will be done. Drawings to check over. If you want.
Line loads. That's linked to the axis and the definition, if it is 3D, that means you have the vertical slope as well.
Yeah. Yeah.
So be careful.
And I'll tell you, how it goes is suppose you have got that case you apply loads at that case there is option for projection. You say that you take everything, all those it will apply all those elements which are 1 meter. So there is a
So that projection need to be constant or if it is a varying projection,
अगर आपने 1 मीटर दे दिया तो उसके 1 मीटर में जितने भी आएंगे उसके ऊपर वो लगा दें.
whether it is anything
Less than
one,
1. I think we discussed this in the first on the first day. So the option in Sophie Plus, I think I told you. No? It's very here only. It's just projection in element and range of application. You give it 1 meter. So back to the report. रिपोर्ट में वो दिखाएगा कि कौन से एलिमेंट्स पे वो अप्लाई करें. Go to
First I know.
Excel, extra, both syntax. Basically, access plans.
See, earlier things were now it is just Excel as read.
Once your file system.
So here
Access time sheet.
यहाँ पे वो सारा वो ये है पहले क्या करते थे कि पहले from 2024 it is just and it's just like, automation that I happened to do once. Citizen करते थे लोड केस नंबर other parameters वगैरह थे तो काफी अच्छा एक्सेल शीट बना था but need to do it all manually like that input manually output reinforcement manually then he used to go and optimize it further manually वही वही करने के लिए फिर थोड़ा मेरे को बोर हो गया I just found a way. I went back after 2 days and मैंने क्या किया कि the technician मेरे को ना सारे स्लैब्स का ना ये डेटा जो है ना लेंथ एल और जो भी उसका whatever the data is मेरे को उसमें first row then it's LX LY these 7 8 data points 2 these 7 8 data points S3 these वो एक सेपरेट एक्सेल था मेरे लिए और एक शीट था वो सेपरेट था वो तो जाके पेस्ट करेगा मटेरियल लेगा पेस्ट करेगा मतलब जो ह्यूमन जो करने वाला है वो सीधा वो जो मेरा जो कोड था VBA का वो उठा के वहां पे डालता था उतना ऑप्टिमाइज करने के लिए क्या करते हैं डेप्थ चेंज करके देखते हैं उसका सेल्फ चेंज होता है फिर वो ऐसा लगा दिया कि इसको 60 mm से लेके चेक करने को चालू कर दो 60 डाल के जो भी था ऑप्टिमाइज आउटपुट बाहर आता था 70 ऐसा कर दिया देखा मैंने एक दो बार और ऐसा ही चलता है तो एक के लिए किया था फिर मैंने उसको स्लैब्स हॉस्पिटल बिल्डिंग का 40 सेकंड में बाहर फेंकता था सब 40 सेकंड ऑल आउट इन 40 seconds nice print out in A4 format I went to task they used to do for मतलब weeks together फिर वो आने के बाद फिर वेरीफाई ये वो सही है गलत है ये है मैंने बस चेक किया बीच वाला एक उठाया चेक किया मैन्युअली हाँ ये सही है क्योंकि वो शिट इतना ढूंढा क्या बताऊँ वो मिल ही नहीं रहा पता this is how it goes why automation is this yeah और yeah as an engineer you should learn things no doubt and you need to deliver right पैसा भी तो आना चाहिए उतना स्पीड में okay not to deviate from the topic let's just proceed so what else are we left with so you get how to make the steady files and all right what else are we left with
Right.
Yeah, that is one. And yes, load combinations using SSD, that is one we are left with. मतलब आपको कैसे कि but the problem with that thing was, let me give a disclaimer
सर
as
एक वो
well.
भी होता है बचे ना FEM वो MSHP
Yeah.
वो
Yeah. It down somewhere. So PMS analysis and this flows, right? So the problem with that thing is मेरा जो काम था रेगुलर वो छूट गया और कॉलम का भी ऑटोमेट ये क्या है.
with automation.
So what I do is there are already loads over here. Okay.
सर
इसमें तो हो रहा है
लंच क्या मंगाना है
Honey?
No.
So we do right click and I say so I do right click and I say insert task called combine loads. इसमें डालता हूँ insert task and the name is combine loads. Where combine loads. I want to combine loads basically. Okay. I double click on that. Like here is my load case number and my type is ULS now. Okay. Or let's say that it is SLS. Right? SLS characteristics. And I just add here. Okay. Simply say okay. 1000 नाम का लोड केस है जिसके अंदर मेरा अलग अलग लोड केसेस में उसको क्या बोल रहा है. I'll just export it once. Let me give it a run. So I've created a new load case named 15,000. Okay, titled 15,000 जिसके अंदर मैं सबको ऐड कर रहा हूँ. Of all these, it's a combination. Now if I do one more combination, let's say it's for ULS now. Okay, I can do now here same. I can just change this factor from here. Then what I'm doing. So these are two. We can do it like this as well, but it is very slow approach. But कभी कभी ऐसा होता है दिमाग ही नहीं चलना है. एक सिंपल स्ट्रक्चर था मेरे को नहीं जाना था वो 1.5 का फैक्टर लगाने सबको था ऐसा. अब मैंने बस कॉम्बिनेशन कर दिया और एक टास्क डाल देता हूँ. तो कंबाइंड लोड्स जो भी लोड 15,001 है मेरे पास लोड केस यूएलएस फंडामेंटल कॉम्बिनेशन में. वो तो मैंने उसको एनलिस्ट कर दिया. What I further do is I insert one more task और मैं उसमें बोलता हूँ combine results. तो क्या पहले डेड लोड लाइव लोड वो सब डिपेंड यू अंडरस्टैंड द डिफरेंस कंबाइंड रिजल्ट, लेकिन कंबाइंड रिजल्ट करने के लिए मेरे पास पहले मेरे डेटाबेस एनालाइज रिजल्ट्स होने चाहिए. That's the reason what I do is I first go to linear analysis and I say calculate linear analysis, which is there in my database over here, one and two. Now I can say that I want to combine the result for my load case one and load case two. वो दो ही आएंगे, जो है database में वही आएगा फिर यहाँ.
लेकिन इसकी जरूरत ही क्या पड़ती है, क्योंकि जब हम कॉम्पिटिशन देते नहीं है तो एसएलएस के लिए भी सैकड़ों केस बनते हैं, सारे केस बनते हैं जिसमें
मैं आपको ग्राफिकली दिखा रहा हूँ, वो टेक्स्ट बेस्ड दिखाया था.
अच्छा
मैं दिखाया था, अभी मैं इसको आपको इसमें दिखा रहा हूँ ग्राफिक्स में.
नहीं, वो ठीक है, ग्राफिक्स दिखा रहे हैं। जो आपने पहले तो एनालिसिस ऑफ द कंबाइंड, आपने जो उसमें कॉम्बिनेशन दिया है, ये अपने आप सॉफ्टवेयर ले लेगा, फिर आप दोबारा कर रहे हैं कंबाइंड रिजल्ट निकाल रहे हैं, अलग अलग आप निकाल रहे हैं। जो हमने पहली बार किया तो वो रिजल्ट तो सेम ही होगा। जैसे मान लो डेड लोड का एसआईटी का अलग कॉम्बिनेशन हमने बनाया होगा, डेड लोड एसआईटी लाइव लोड का हमने अलग कॉम्बिनेशन बनाया होगा, ऐसा बनाते हैं कॉम्बिनेशन में आप लोग क्या है, तो वो पहले जो रिजल्ट आएगा जो भी रिजल्ट आएगा तो सेम ही होगा।
तरीका अलग है, बाकी सब सेम है.
बाकी
तरीका अलग है, मतलब आप ऐसे भी कर सकते हैं, लगेगा वैसा. मतलब मेरे को भी अगर बड़ा स्ट्रक्चर ब्रिज मॉडल का ब्रिज के केसेस अपने बहुत सारे बनते हैं, तब मैं टेडी से कर उसको टेक्स्ट पे से. कल मैं कोई बिल्डिंग में चेक कर रहा था, कुछ मेरे को बस 1.5 करके सारे लोग कंपनी टेक्स्ट वगैरह खोला, टाइम भी नहीं था, मैंने उसको ये ऐसे कर. तब थोड़ी अपने को उतना एसएलएस रेयर 0.9 ये वो छोटे छोटे टेक्स्ट पे. ठीक है, व्हाट एल्स.
वाला मॉड्यूल
टेडी का ये टिक की बात कर रहे हैं क्या आप? है ना अभी
संडे already running किया वाला हम लोग का. So I want to check last time कब run किया था वो.
डेटाबेस में एक फाइल है गूगल इट इज फॉर ऑल प्रोग्राम्स, और वो सबसे ऊपर ही आता है. इसमें मैंने वो देखा है. आप यहाँ पे जाके देख सकते हैं, ये लोड टेस्ट आता है ना, ये ट्री यहाँ पे मेरे को भी पता चल रहा है कि मैंने लोड टेस्ट 1 2 मैंने. हाँ लॉग फाइल तो आना चाहिए, लॉग फाइल आते हैं. लेट मी सी हियर इन दिस. मैक्सिमम करके रन किया था ना हमने, अभी जो था ना एक को हमने सुपरपोज किया था, तो उसके बैकएंड में मैक्सिमम चल रहा था. Let's now discuss. So this was about combinations using graphics.
एक छोटी सी चीज होगी,
Yes, yes.
एक छोटी सी जो मॉडलिंग दिखाई देना,
Uh,
और टाइम भी लगेगा तो बता दीजिए ऐसे करके, ये हो जाए तो हो जाता है इसमें मान लीजिए मेरा वेरिएशन में जैसे मान लीजिए एकदम
विड्थ आपका बढ़ रहा है।
हाँ रेडियस भी यूनिफॉर्म नहीं है, या इन रेड में मान लीजिए 0 रेडियस है और 3 मीटर जाकर के रेडियस जो है कि इंक्रीज करना शुरू हुआ।
मैं बोलता हूँ इसमें कैसे।
टाइम भी चेंज हो जा रहा है, एक तरफ मान लीजिए कि 8:30 में कह रहे थे तो उसका 70
आपका ऐसा है स्ट्रेट लाइन है फर्स्ट ऑफ ऑल, योर रेडियस इज 10,000,
राइट।
बहुत बढ़िया। स्ट्रेट लाइन, ठीक है। अभी ये केस में क्या होता है, साथ साथ इसमें ये भी हो रहा है कि आपका जो बॉक्स है तो 2 सेल आप बोल रहे हैं, 1 सेल का 2 सेल हो गया, 2 सेल का तो आपको अगर से यहाँ तक जाना है ऐसा, तो ये एज गुड एज अ टेपर्ड सेक्शन का प्लान नहीं होता। लेकिन टेप होता है कि वो स्ट्रेट लाइन करके ज्वाइन करते हैं और आपको स्ट्रेट नहीं चाहिए अभी ये बात। तो आप क्या कर सकते हैं उसमें, अगर क्रॉस सेक्शन में अगर देखा तो वेरिएबल करके एक पैरामीटर था वहां पे, वेरिएबल एक्सिस सेंटर, देयर इज अ वेरिएबल लेट्स से विड्थ w, okay, axis at every point 1 meter, point 2 meter, point 3 meter, point 4 meter, 5 meter, so on and so forth. So हर point के लिए on your axis you can give value। ठीक है, फिर नहीं तो let's say realistic थोड़ा फ्री ग्रेजुअली उसको इंक्रीज करते जाना। प्रॉब्लम ये हो रहा है कि 3 पॉइंट चाहते हो कि स्ट्रेट ही जाए, लेकिन आप चाहते हो कि स्ट्रेट ना जाए, पॉलीगोनल वो शेप ले, तो वहां पे एक ऑप्शन पॉलीगोनल करना है, स्प्लाइन करना
पॉली चूज करेंगे तो ऐसे
है,
कर्व में आ जाएगा।
करेंगे तो उसको ऐसा बेली शेप लेके वो ऐसे एक प्रोजेक्ट था उस दिन।
डबल सेल आएगा जो है, तो वो तो खैर सेक्शन में दिखाएंगे अपने,
सेक्शन में हो,
वो तो सेक्शन में आएगा।
मतलब आपको यहाँ पे अलग सेक्शन डिफाइन करना पड़ेगा, यहाँ पे अलग सेक्शन में बोलता है वो भी कैसे शेड्यूल के सामने मेरे पास बॉक्स निकल रहा हूँ, आपको बताना नहीं निकल रहा। ठीक है, नेक्स्ट जो है क्या रहता है, इट इज एन ओपनिंग पर कंसर्न फॉर द विड्थ इज ओनली, क्या आएगा कि उसका बाउंड्री बढ़ गया है, बाउंड्री यहाँ से यहाँ हो गया एक्सटर्नल बाउंड्री, आपका कनेक्शन इसका इसके साथ हो रहा है, इसका इसके साथ हो रहा है, इसका इसके साथ हो रहा है। अंदर जब जा रहे हैं आप, जो अंदर वाले वर्टेसेस है उसमें बस आपको, मैं गलत बोल रहा हूँ, इसके भी वर्टेसेस इसको जोड़ने पड़ेंगे।
कैसे करें वो जो है कि वो कैसे होगा।
तो बनाते टाइम भी तो एक कोई क्रॉस सेक्शन होगा जहां से हमने फिसल चालू किया है,
तो
वहाँ पर एक
आपको
क्रॉस
क्या
सेक्शन
करना
देना
पड़ेगा
पड़ेगा।
बोल रहा हूँ,
हाँ।
आपको
मैंने भी देखा है, मैं बता रहा हूँ कि
Direct
ये
तो होगा नहीं,
एमपी के अंदर जबलपुर के पास में एक जगह है जहाँ पर ये 2 साल से 3 साल हुआ है, बहुत पुराना बिल्डिंग, आज का भी नहीं है वो।
हाँ क्या,
हाँ तो वो बना हुआ है।
आपको एक जंप लेना पड़ेगा, जंप लेना पॉसिबल है, लेकिन मैं ये जो बोल रहा हूँ स्मूथ, फिर आपका ऐसा आएगा यहाँ पे तक एक क्रॉस सेक्शन आएगा, फिर हालांकि दोनों का ऑलमोस्ट सेम ही रहेगा, का जब बंद है, बट वहां पे आपको फिर क्रॉस सेक्शन दूसरा लेके उसका ट्रांजिशन नहीं मिलेगा आपको, अंदर वाला नहीं मिलेगा, बाहर वाला मिलेगा। तो इसमें भी किया, यहाँ पे मैंने मॉडल नहीं किया इसलिए जंप पे हो। सेक्शन अलग है डायफ्राम का और इधर अंदर वाला सेक्शन अलग है. Yeah, so सोफी एमएसएच ए पहले डिस्कस कर दे. मैं तो पहले रिस्पांस स्पेक्ट्रम में देखते थे. ओके.
एक ये भी था धीरे
कैसा?
जब टेम्परेचर में जब हम कि जो टेम्परेचर होता है बड़ा होता है
सही है.
इसमें दिखाई
कोई प्रॉब्लम नहीं. मैंने लिखा है ना आपको. हाँ, वो देख देखो मैंने वही लिखा है.
इसमें अब हम लोग सॉइल स्प्रेड कैसे देंगे?
बोल दो. So I am just opening a model from a user. Okay. मैं लैपटॉप खोलना पड़ेगा. नहीं तो इसमें भी करेगा. स्पेक्ट्रम का डेफिनेशन है और फिर आइगन वैल्यू एनालिसिस करता हूँ और फिर आगे करता हूँ. तो स्टेप इज दैट आपका
तो मैक्सिमम पीरियड खुद कैलकुलेट नहीं करेगा सॉफ्टवेयर या
ये इसके लिए नहीं है. वो रिस्पांस स्पेक्ट्रम की डेफिनेशन के लिए.
अच्छा
रिस्पांस स्पेक्ट्रम का जो 4 तक जाना चाहिए और 4.5 तक जाना चाहिए, 5 तक जाना चाहिए, उसके लिए
ओके
लोड केसेस रहेंगे रिस्पांस स्पेक्ट्रम के. देखो क्या है, ये सोफ्यू लोड है, ये लोड केस है. आर ई एस पी स्पेक्ट्रम डेफिनेशन. Type is IS. Class is soil class that you want to give. Zone is zone you want to give. Damping ratio that you want to give. SA, SB, S mean. These are all parameters associated with your response spectrum का वो जो ratio जो रहते हैं ना, आगे चलो. TD भी उसके लिए है, मतलब ये these things, okay, from scratch. What you need to finally do is you need to simply give it a run, okay, and open the report and see what response spectrum. Let me just say, no.
और फिर पैरामीटर था ये समझने के लिए ये
मैं पहले आपको ग्राफिकली it works is, let me go back to this file. Says buildings, but let me check. The task, this is mainly for buildings actually. That's why I did not want to show you this task. But it goes like 1001, 10,002 up to 10,011 like that. Then select the solver that you want to go with. Then you can give damping and stiffness and internal effects basically based on the group number. Some stiffness things, then you can consider, of course. Possibility to define groups and secondary groups in Sofistik, which we did not explore or did not study, because that is not, we can do that. Then there is filtering, but maybe that is not required. It's not filtering of frequencies, but total mass participation in the direction. Okay, 90%. Okay, it's that. It's not frequency filtering. That's fine. And this is eccentricity over here. Next comes is definition of response spectrum. You can define response spectrum as per IS 1893. Okay, and factors over here. Frankly, I never use this graphical input ever in my practice in the class, but you can simply if you want to update these parameters, then you can update it from here. If you are not happy with this time period going up to only 4, in our man response spectrum definitions in 3 different directions, X, Y, and Z. Okay. First, you go for eigenvalue analysis, then you go for response spectrum definition. Then you go for result and output. You only ask for what output you want. So you see over here it is result item is node support force in global X direction. Over here further SRSS and all available result items, and you can by beam MZ, so on and so forth. So it will perform response spectrum analysis and only store those results. Maybe bending moments and by MZ shear forces, axial forces, also the displacements you want to see in after as a result of your response spectrum. And third is going for response spectrum analysis. Now, let me show you a model file.
कॉम्बिनेशन मेथड कौन सा करना है? CRS, CQC, SRS, ये कुछ वो रहता है फ्रीक्वेंसी के ऊपर
तीन मेथड रहते हैं, तीन को इसमें ऑप्शन होगा
ऑप्शन में
ऊपर दिया है।
नहीं, ये दो यूज करते हैं CQC, SRS, ये कुछ मॉडल
बेटर रिजल्ट देता है, कुछ को बेटर रिजल्ट देता है, वो बेटर रिजल्ट देता है।
So I have studied this, but I don't know what exact distinction is. I know what SRSS is, what it exactly does. It is only some of the results that you get. It is all because you cannot directly add your result output from your dyna or the response spectrum analysis. You need to. This is like a method to reach down, boil down to that output for a structure from given modes, output of the given modes. I don't know what CQC does exactly.
I even I am
आर्ट में ही है कुछ, आई थिंक जितना मेरे को रिमेम्बर है उतना कुछ मॉडल फ्रीक्वेंसी।
फाइंड करने का मेथड है कि ये तीनों पे डिफरेंट मेथड्स हैं। कुछ केसेस में वो बेटर रिजल्ट देता है, कुछ में ये बेटर रिजल्ट देता है, वो डिपेंड करता है
So,
टेक्निक हो जाती है हम
कब कौन सा यूज करना है?
बस ये एसआरएस यूज करते हैं।
Sir, SS का use किया था to work out reflections and expansion back for MPH.
Okay.
CQC.
And
CQC कभी use करते हुए देखा नहीं है।
मतलब मैंने पढ़ा नहीं, वो पढ़ाया नहीं है क्लास में, ये बोल रहा हूँ मैं।
कैसा है सर, वो बिल्डिंग्स में मोस्टली यूज करते हैं जब अर्थक्वेक वगैरह।
आर्टिकल तो नहीं है।
वही अर्थक्वेक के लिए
तो सीधी साइड
मैंने कहीं लिखा हुआ था कुछ फ्रीक्वेंसी।
वो enough more so.
डिफरेंट मोड्स को कैसे कंबाइन करना है उसको नेट रिजल्ट के लिए वो डिफरेंट मेथड्स हैं, तो डिफरेंट मेथड्स सीखने चाहिए।
तो ऐसे है। If you write it anyway. So this workflow, and what happens is if I file दिखाता हूँ, यहाँ पे सोफी लोड मॉड्यूल यूज किया, अगर आपने उसको राइट क्लिक किया और टेडी फाइल अगर जनरेट किया, एंड ऑफ स्ट्रक्चर। Find Sophie loads over here, okay, and load case number one is to define response spectrum in x direction. Acceleration direction is AY1, and this is AZ. It's response spectrum RESP type. It is highest. Class is one, so soil class basically. So you even if you give this 5%, it it takes 5. So it is damped, it's not damping ratio basically. So second SB concentration and all. So I don't usually get into all these details, but what I do is identify what it is, this AG. Basic acceleration. Okay. L by 2, I by R. So this. So it is L by 2, Z is I is 1.5, R is 3, and since it is SA by G, then we pick 9.81. What I say is the direction has to be directly this one. The acceleration direction is this. So it suppresses, all your previous input. I have a response spectrum model for you. Then here is eigenvalue analysis. So here, whatever the input you type is, here it says that method of Lampos, and LC is there is possibility to define us from different load cases. It says that PRZ is 100. But over here, if you see, okay, this might be a live load. By direction, it is only 50%. Direction, you don't want any, so you can just do it 0. The stiffness here will be 75% stiffness. And for eigenvalues, vectors, that is all. Even if that works, but in that case, you don't know what. Then comes the module dynamo. Okay, the third table. Now you would want to extract results of your MX, all those spectrum analysis based on. So this does it. This says that this 1001 to be analyzed. Dyna is a module for that. Okay, Dyna is module for response. So what it will do is maximum value of axial force. Store the maximum value in lowercase number 2102. Similarly, maximum MY will be stored in 2107 and maximum minimum MY will be stored in spectrum analysis in the X direction only. 1001. LC 1002, similar results evaluation and storage in the
corresponding moment भी देगा
yes, corresponding moment with the
मतलब maximum
storage हो जाएगा.
storage हो
अलग
जाएगा
अलग location.
corresponding होगी
Corresponding with it.
Maximize N and give you all corresponding value.
Yes.
And next may say MY, to maximize MY and give all those.
All corresponding with. Similar format as what we do in the video. Section may you go for the response spectrum analysis. What you next do is take an envelope of the load from 2101, 23, 12 in maximum view. So that of all your earthquake cases. ताकि आपको ये ऊपर क्या है 2102 में वो सब देखने की कोई जरूरत नहीं. Earthquake बोले तो एकदम go and take an envelope in we get to see the result in different directions. So it's only in the y direction. But let's say whatever this thing is, then you get further maxima calculation in our regular, pre.
Fine, say, these are your files.
This one,
85.
this one, sir. Actually, I have made a nice, for like. Oh, but it's fun, huh? बोला होता. So we open some. I explained you that there was a template at the top, right, for response spectrum analysis. It's not there, but it will be in the same format, wherein for this, for example, this file has got a template, then it will have all response spectras. Okay. Here, response spectrum analysis. Yeah, you see, here is a template. You need to simply give input to your templates. Further, it goes, it's three response spectrum as per IS. Now, what happens is that this is as per some inbuilt functions in Sofistik, and people are not happy with it. क्या है कि इसमें जो भी रिस्पॉन्स स्पेक्ट्रम भी जनरेट जो होता है इट डज बेस्ड ऑन पार्टली बेस्ड ऑन यूरोपियन स्टैंडर्ड it takes it a straight line here again another straight line and like this. So there is small discrepancy but even a model file इसमें कि मतलब 0.1 second point not 1 second p is point not 2 second not and SAYG values I have just mentioned there is an Excel file वो मैं आपको भेज सकता हूँ. This one. So you don't need to. That is a function that has got t values and SAYG values straight away. Correct? You know? And that as well. Further is what it further does is it goes for eigenvalue analysis. Here you see that it was not complex case. So here is an AS and it is just command. That is all. And in the next this it is they are going with CQC and here is a template going with CQC number of eigenvalues and load case number for lowest spread over here. So this is the direction of results in y direction and this is in so on and so forth. Right? So well set steps you need to simply put in the template, change the template values or same thing. If you do right click and then give input and then that daily task can be open from here, it will be exactly the same. Always a good idea that particular response spectrum analysis on one single small column. Yes, and look at your manual results and results as per the response spectrum analysis. Right? So, this is other way.
Tracking or stiffness 0.75 here. How do you calculate? Can you calculate the crack stiffness is also in this one? That's a very good.
So what it does is to go for nonlinear analysis, material nonlinearity, enforcement, and concrete material appropriately. आपको सब मॉडल का मॉडल process of that element. मतलब what is nonlinear stiffness and gradually you go here, but it goes iteratively. So gives updated stiffness in each of the iteration that you get. Asking for a member, right? Member stiffness wise. generated. It's not that it cannot be generated. This was asked to be
Generated and then you have to re-feed it into the system. Files or readings. How do you go for the convergence, basically? You get the
no,
text.
no, no. So it will run the but during the iteration thickness value that will be shown in the report in each of the iteration.
We can converge them directly.
We do a lot of
मान लीजिए सेकंड क्रैक हो गया तो इस डिफरेंस की रीडिंग होगी
reduce.
उसमें इंक्रीज करेगी उसी सेम द
I'm not saying that. I'm not saying that, sir. I'm not saying that. होता क्या है कि आई एम नॉट सेइंग मटेरियल का स्टिफनेस के बाद प्रोग्राम डज दिस आपका एखादा एलिमेंट है ठीक है सो डार्क
थोड़ा आपका फ्लाइट है क्या?
टाइम फॉर मी टू लीव जब अपन लीनियर एनालिसिस होता है स्ट्रेट लाइन पे नॉन लीनियर एनालिसिस में क्या होता है कि आप जैसे बोल रहे हैं कि अब सॉफ्टनिंग हो गया अब तो मटेरियल बट प्रोग्राम अपना क्या है कि जैसे कि आप देखते हो कि वो जितना नंबर ऑफ नोड ज्यादा लोगे तो कर्वेचर में ज्यादा एक्यूरेसी देता है स्ट्रिक्ट चीजें समझते हैं तो यहाँ पे जाके ये क्या करेगा ये स्टिफनेस लेगा और वो एनालिसिस परफॉर्म करेगा लेकिन दैट विल बी एबल टू रिटर्न ऑप्शन के हिसाब से फिर वो ये वाला पॉइंट पकड़ेगा और फिर थोड़ा एनालिसिस करेगा तो और थोड़ा डेटा करके ऐसा कर करके आइट्रेशन से वो इसके लिए जाएगा तो ये जो एक्यूरेसी जो बढ़ा है उसकी बात कर रहे हैं इट्स नॉट दैट स्टिफनेस इंक्रीज वो नहीं ये प्रोग्राम को बस ऑप्शन से कोई मेनी नेम्स लैंग को है ये I happen to use for many of them for some reason वो कन्वर्जन नहीं होता ask a programmer okay, who developed it which one to use so for numeric what is the reliable result how would I know so I happen to perform nonlinear incremental dynamic analysis for checking table test. System and like I got to realize how softening takes place and displacement values change. What is the response? How expressions values are affected and all that. In that case, I had to use many like this. And in that case, also earthquake input intensity was increased from 0.05 G to 0.1 G in the next loading level. The next loading 0.15 G, zero point 0.2 G. That was experimental things, right? Checking table test. तो उसमें हैमर करके टेस्ट करते हैं तो स्ट्रक्चर का पीरियड हम इवेल्युएट कर सकते हैं earthquake intensity test and the
एटीट्यूड वगैरह फ्रीक्वेंसीज वगैरह निकाल वही ना?
That's how
हाँ
you filter the frequency.
फ्रीक्वेंसीज
पे उसका जब सिमुलेशन जब कर रहा था तब वो last topic, last point, anything is okay. Last is SOPI message. We have got 6 more minutes. Let's just follow that. Okay. So what happened is what we did is okay. So there are two approaches to modeling. Okay. Geometry. Our test on a bridge. Accelerometers, wired potentiometers, LVDT. Concrete. Concrete.
एक्सीलरोमीटर में तो
used in my tech thesis.
And what was the span?
Huh?
What was the span?
Alex cantilever.
Hammer still time
वो ऐसे
बहुत दूर नहीं, कोई दिक्कत नहीं, पासिंग में है।
मेरे को मेरे को वो भी नहीं ठीक। So in impediment test, what you will get is you will get a time history of responses. From that response, you will have to extract what is the time period. तो उसको पूरे ट्रांसफॉर्म करो, एक बार चेक करो, फिर वो मैन्युअली जाके चेक करो, उसको भी डेटा फिल्टर करो. You need to take out because it is all modes combined, right? The time history that you get has out the data for one mode in the direction of your interest. This is what the free vibration. If your time history is so shaky like this, okay, too shaky with all of frequencies. अगर आपने एक मोड के लिए अगर filter out किया जिस direction में time period निकालना चाहते हो, such a nice curve like this, showing very well damped structure, very nice curve. But you should be able to filter.
फिक्स किधर गए थे एक्सीलरोमीटर्स? नीचे सॉफिट पे गए थे या स्लैब में?
For but I'm not just for such big structures. So one very pretty long.
तो वो जस्ट उसके लिए जंप भी करते हैं.
That is only just 1.5 kg.
Sufficient is so that accelerometer is so sensitive.
Yes,
Hmm.
that is.
So sensitive. Even if you just sufficient action. इतना sensitive.
हाँ अभी कहीं देखा था मैंने.
So the test, see that was 3 meter high, so 3 by 4 by the structure that I was. Wooden block. Not even this. It was a wooden block. बहुत ज़्यादा acceleration generate करता था. But that accelerometer is that captures at data point at every point, not 1 second. So in 1 second you will have 1,000 data points. Time history अगर capture करते तो one accelerometer. I had used around 20 accelerometers in the structure. So अगर वो data copy किया paste किया एक से
डेटा आगे तो बहुत सारे फिल्टर लगा देंगे आपने, कैसे कैसे नेचुरल फ्रीक्वेंसी
उसको response for that particular mode. तो आपको ये फ्री वाइब्रेशन रिस्पॉन्स मिला. फिर आपको ये पता चलता है कि यहाँ से यहाँ तक ये साइकिल आने के लिए कितना टाइम लगा. दिस टाइम तो आपको उसको पीरियड मिल जाएगा. 50 पूरे ट्रांसफॉर्म. पूरे ट्रांसफॉर्म में वो आपको वो सही लोकेशन पे पिक मारेगा, वहां पे जहाँ पे पिक आएगा वहां पे उसको.
लेकिन डेटा आएगा ये जरूरी नहीं है ना कि नेचुरल फ्रीक्वेंसी वाला डेटा ही हो. बहुत सारे फ्रीक्वेंसी में
आपको वही बोला जो फिल्टर filtering is purely based on the judgment. पहले फाइनल एलिमेंट एनालिसिस करो ताकि रफली इसका पीरियड शुड बी बिटवीन को डिस्टिंक्ट डेटा
इतना आसान भी नहीं होता।
हम ये तो
चेक
इसमें कर सकते
आपने वाई डायरेक्शन का डेटा लिया एक्स डायरेक्शन का लिया वाई डायरेक्शन में इतना फिल्टरिंग किया इसमें एक्स में इतना फिल्टरिंग किया तो आपको समझ में आएगा अरे ये तो एक्स है
क्या जगह कर लिया वैसा वैसा नहीं है।
नहीं, ये तो हम उसमें यूज कर सकते हैं ना हेल्थ मॉनिटरिंग में, मतलब जहाँ पर मेरा स्पाइक आ रहा, फ्रीक्वेंसी चेंज हो रहा, तो फिर
वही बात कर 19 and showed
100.
800 sorry 800 sorry Bingo. Went over there and the problem always with our structures is measuring deflection is a challenge because you can measure acceleration to get your the challenge now in this was सच में 1800 ही है 800 ही है या deflection measurement system बताना चाहता हूँ that bridge would have been like this and bridge right रहता है easy to watch reference चाहिए रहता है support चाहिए रहता है लेकिन because it is not possible in such a depth and all so what I did is not me alone सबका मिलके कैसे कैसे so we installed a tube from here to here okay install pressure gauges at different locations install a tank over here with the water तो इसका जो प्रेशर है सेम लेवल पे सेम प्रेशर देना चाहिए उसने हर बार अगर यहाँ पे सैग होता है तो उसका हेड यहाँ पे चेंज होगा तो आप फिर मेजर करेगा देखो प्रेशर का आउटपुट आएगा जिसके ऊपर से मैं हेड कितना चेंज हो गया वो निकालूंगा not 5 seconds I used to get change in the head value based on the changed head value I used to say that ये टाइम पे इसका डिफ्लेक्शन ये है that this reference point on top of my PS is at constant level this was the assumption that तो इसके ऊपर से गड्डी गई इधर स्क्रीन पे दिखता था गई रिपोर्ट कर कोई तो कुछ तो गड़बड़ that was for SPC lab see that the bridge did come back to its there was 100% recovery in all the tests that we performed Fucker की जगह it is near Chitkul Indo-China border शिमला से आपका in real time
क्वालिटी सिस्टम जो है आजकल तो ऐसे जैसे कि एक्सपेरिमेंटल आ गया है मेजर करने ऐसे दूसरे भी तो आते हैं क्या बोलते हैं उसको जो है कि लगा दिए तो एग्जैक्ट आपका एग्जैक्ट डिफलेक्टर देगा
डिफ्लेक्शन का ये प्रॉब्लम है सर बाकी सब आ सकता है
एक्सेप्ट को रेफरेंस पॉइंट
रेफरेंस चाहिए आपको अगर किसका डिफ्लेक्शन चाहिए तो आपको प्रॉब्लम है बाकी इधर उधर डिफ्लेक्शन चाहिए बेरिंग पे तो में तो सीधा वो डायल गेज तो ठीक है ना लोड टेस्ट में 50 मीटर नीचे है तो नहीं तो आपको दूसरा ब्रिज बनाना पड़ता है इधर
फर्स्ट से
इसमें काफी सेविंग
Other thing, normally protest, but you would like, your hospitals.
Time to demolish.
No, I was
Then that is not the solution. That is the solution if you have got a constant error to be continued everywhere.
new bridge road test generally skinny blocks and bridges where we cannot go from that.
Okay, last point, so message A, every 2 minutes. Sorry for
But it's interesting here sharing these things. The market traders, the industry meaning here, so they do not understand or they don't know all the experience. Good that you have both industry experience and business.
so what happens is that what we studied now is was SOPI MSHA. Sorry, SOPI MSHC. Okay. What we did is how we speak teacher. Okay. So can you please take a photograph? Fine. So we define SPT NO number was 2. And what we further did is we went for SLN and we said that N1 to NPE2. And so node 1 was here, node 2 was here, and we connected it with. So first we define this node 1, node 2. Further additional nodes were generated. So what Sophie Plus does is this. We create a line first, when we export, then it meshes an additional nodes are put. The approach that STAD uses is that do is that would put 1, 2, 3, 5, 6 separate manually. For this approach. But manually you need to input 7 nodes or 10 nodes, whatever it is. So this approach is Sophie MSHC uses. This is approach is uses. This is the difference. How it helps is this approach helps is you can define a curvature, one single line, meshing and nodes generation is its task, not our task. But how this is a problematic, for example, I have got another line that is crossing over here. It will automatically create a node over here. It will get connected. But if you want, in this case, another node here, and node here. No node in between, there won't be any.
Use MSC.
So both are available. This is also not a pie cap like this. And there are piles below. Vertical lines. You have to create nodes here like this. Create nodes on its own and establish rigid connection. All of this line coincides properly. Yes, that it is not connected, this and that. In big structures, it becomes a massive problem, especially structures like stations and all. It, to perform eigenvalue analysis, then your first period will be into it. It will be very much flexible in that case. That will be a problem. SH में ये problem होता है कि connectivity becomes a problem.
Find out the
find out the exact location, exact things, and
places you have to define.
एग्जैक्ट नोड कनेक्शन करना पड़ेगा. अगर ऐसा होगा कि आपने गलती से ये जो नोड है या इस जगह पे यहाँ पे तो वो कनेक्ट आपके एनालिसिस में प्रॉब्लम्स आ जाएंगे कि इसके ऊपर लोड ही नहीं ट्रांसफर हो रहा है, 3 फाइल पे लोड ट्रांसफर हो. For listening to me for 3 long days.
We still will be factoring one number of queries.
Yeah, sure. So do we have okay, so I will send you the feedback form. Email, please fill in. Sir.
That's what's the plan.
Okay, next. Common line. Okay.
So नहीं cover नहीं है. Language पे भी काम में ट्रांसफर कीजिए बताओ.
Very specific language. और भी यार कौन से पार्टी में था हुआ वो पता नहीं.
अच्छा.
But there was सुशील सर आप हो. प्रणाम. तो सिर्फ मैंने आज ये किया वो किया वहाँ पे सुशील सर आपको भी हम ठीक है सर. Every day he comes with names or मतलब नॉर्थ. And your
After P3.
Piple,
P3.
Pitri.
नहीं छत्तीसगढ़.
छत्तीसगढ़ का. Okay.
कृष्णा जोशी.
Okay, thank you. I'm a POT. And so I am a vegetarian. Thank you.
Thank you.
Thanks everyone. Wish you all the best with your this venture. Happy use of Sofistik.